Hello, this is Rami Al-Rajab. Chapter 2, Section 1. The Human Ear. Our ears are always listening and cannot be turned off. The human ears are fascinating instruments. Each ear consists of three parts: the outer ear, middle ear, and the inner ear. The three components work together so you can hear sound. To simplify the process, hearing starts at the outer ear, which carries sounds from the air through the ear canal to the eardrum. The eardrum vibrates, which causes three bones in the middle ear to move mechanically. And finally, the middle part sends mechanical vibrations to the inner ear, where they are picked up by hair cells, which send electrical impulses to the brain that translate them as sounds. Be careful. The tiny hair cells in the inner ear are the most sensitive and very important, because when those hair cells are damaged, they do not heal and can cause hearing loss. Chapter 2. Human Perception of Sound. Human perception of sound plays an essential role in identifying whether it is noise or a pleasant sound that we hear. Having two ears help us to determine the direction of the sound waves. Our brain is intelligent enough to figure out that if the sound hits one ear just before the other and it's slightly louder, then that is the direction the sound came from. Our ears act like a spherical sensor, an aura-like sensor around us. They are best to locate sounds in our surroundings and also protect us from danger. Think of a car behind you. Once you hear the sound of the engine or the squeaking tire, your brain receives it and sends immediate warning signals, so your entire body acts accordingly. Clarification of terms. Reverberation. Sound is energy, and sound waves will keep traveling until they lose their power. When these waves hit or face a surface, they bounce off in the opposite direction. And when they hit another surface, they keep bouncing off again and again. These unlimited reflections, especially in enclosed spaces, are known as reverberation. Echo is a delayed reflected sound that to be heard as well-defined repetition of the original sound, caused by bouncing off the sound waves from a usually hard surface. Dissipation. In the case of dissipation, the sound waves is broken up. This is what is required in most living situations, along with a bit of absorption. A room where the sound is dissipated or distributed feels alive without any unpleasant echoes or loud or quiet spots. Now, let's talk about reflection and absorption. Reflection. If there is a sound outside the home, the best tactic is to reflect it back to the outside. Let's take a double-glazed window as an example. The first pane of glass reflects the sound to the outside. Any sound waves which aren't reflected hit the next layer in the double glazing, which is a partial vacuum, so the sound waves can't travel through it simply. Then there is a second pane of glass to reflect any sound waves that remain. Some sound waves will get through, but the double glazing tactic works very well. Absorption. When a sound wave hits a soft material, it sounds like the sound is absorbed. In fact, what is going on is that the sound waves are transformed into a different form of energy, heat. Notice, we don't feel much of that heat because it takes a lot of sound energy to create any noticeable heat. Noise reduction and acoustic treatment are the main factors of soundproofing. For achieving the best result of soundproofing, it is recommended to treat the space or the room with acoustic foam panels. The acoustic foam panels can be easily installed due to their lightweight and ease of handling. There are many types in the market. For example, the pyramid acoustic foam, the wedge acoustic foam, the groove acoustic foam, the egg tray acoustic foam, etc. Soundproofing acoustic panels are commonly used for treatments in music studios, home theater, offices, auditoriums, and cinemas.